So here are the steps for using StatCrunch. Stat, proportion stats, one sample with summary. Typically it's with summary. You would use with data if you had one column with all the categorical data in it, such as yes, no, no, yes, no, 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 etc. Typically, though, it will be summarized for us, this many out of that many. Inside StatCrunch, enter the number of successes, X, and the number of observations, the sample size, N. Click the radio button next to confidence interval, and then enter the level of confidence as a decimal, leaving the method as standard. Let's go through two examples of this. First, a survey of 125 COS students shows that 30 own an iPhone. Construct a 95% confidence interval for the proportion of all COS students that own an iPhone. 125, that's our sample size N. 30 of those own an iPhone, that's X. So P hat is 30 divided by 125. And to check the conditions, I need a decimal for that. That is 0.24. The first condition is N times P hat times 1 minus P hat has to be greater than or equal to 10. N is 125. P hat is 0.24. 1 minus P hat is 0.76. 1 minus 0.24. When we multiply that out, we get 22.8, and that is 10 or above. So that condition is met. Next, we want to make sure that 20 times N is no bigger than the population size. 20 times 125 is 2,500 COS students. Are there more than 2,500 COS students? Yes, there's about 16,000. I don't know the exact number, but I know it's much larger than 2,500. That means that we can go ahead and construct the interval. Let's go ahead and do this in StatCrunch. The last thing that I need besides the 30 out of 125 is the confidence level, which is 0.95 mentioned here. Okay, off to StatCrunch. Okay, here we are in StatCrunch. Press the Stat button, Proportion Stats, one sample with summary. The number of successes was 30. The number of observations, 125. Click the radio button for confidence interval. Since it's 95%, we'll leave that as 0.95 and always leave the method as standard. Click Compute, and there are the results. The lower limit, 0.1651, the upper limit, 0.3149. Here are those results again. The lower limit, 0.1651, the upper limit, 0.3149. That tells us that we are 95% confident that the proportion of all COS students, not just these 125, that own an iPhone is between 0.1651 and 0.3149. Now we can compute the margin of error from these results. The margin of error we can find by taking the upper limit and subtracting the sample proportion, P hat. The upper limit is 0.3149, again right here. P hat is the sample proportion right there, that's 0.24. And when we subtract, we get 0.0749. That means that we are 95% confident that our sample proportion is within 0.0749 of the true population proportion. Let's try one more. In a medical study, 80 patients were given a new allergy medication and 24 experienced headaches as a side effect. Construct a 90% confidence interval for the proportion of all allergy patients who experience headaches as a side effect of taking the new medication. The sample proportion P hat is 24 divided by 80, or 0.3. Checking the conditions. N times P hat times 1 minus P hat. We're checking to see if that's at least 10. N is 80. P hat we just saw is 0.3. 1 minus P hat, 1 minus 0.3. is 0.7. When we multiply that, we get 16.8, and that is large enough. Next, we want to check that 20 times the sample size is no more than the population size. 20 times 80 is 1,600 allergy patients. Are there more than that number of allergy patients? Absolutely. We don't know the exact number, so it would have been hard to take 5% of that, but we know that there's definitely more than 1,600, so we can make the interval. Again, x over n is 24 out of 80, and the confidence level this time is 90%, so 0.90 mentioned right here. Okay, let's go ahead and go to StatCrunch. Okay, here we are in StatCrunch again. Press Stat, Proportion Stats, one sample with summary. This time we have 24 successes out of 80 observations. Click on confidence interval. This was a 90% interval, so we can type 0.9 or 0.90. Leave the method as standard. Click compute. The lower limit is 0.2157. The upper limit, 0.3843, rounding both to 4 decimal places. Again, here's the results. The lower limit, 0.2157. The upper limit, 0.3843. So we're 90% confident that the proportion of all allergy patients who experience headaches as a side effect of taking the new medication is between 0.2157 and 0.3843. For the margin of error, again, we take the upper limit, 0.3843, subtract p hat, 0.3, and we get a margin of error of 0.0843.